Hello everyone, welcome back. Mr. Havel here. We're going to go over 9.1 today, which is all about the ellipse. Okay, so it says an ellipse is a set of all points P in a plane such that the sum of distances from two fixed points F1 and F2 is constant. Okay, and you'll see F1 is our focus and F2 is another focus. Okay, so it says these two fixed points are called the foci. Okay, so just plural with that. The midpoint of the segment connecting the foci is called the center, right? So the center of the ellipse here. So the cool thing is if you take this purple line right here and take one end right here and bring it over to this vertex and then spread this one over here to the other vertex, it'll be that length right there. Okay, so if you bring it in, the sum of that is always going to be that major axis, no matter where you bring the foci in there. Okay, so standard form of an ellipse. This is the kind of the parent function here, where without any movement at the center or anything like that. Okay, so our center in this case is going to be at 0, 0. Okay. Our A is going to be in this direction, in the X, because A is underneath X. And then the B is going to be a vertical component because B is under the Y. Cool. Now, same idea with the equation, but now I have it with HK. Okay, and so our center is now going to be the opposite of H and the opposite of K because of these minus signs. Cool, so it'll be the opposite sign on both of them. Same exact thing with A and B because of where the A is located. So A is a left and right thing, B is an up and down thing. Cool. It doesn't have to be under the X and under the Y, respectively. They can change. Okay? So it says here, if A squared is greater than B squared, then the major axis is the horizontal. Okay, so meaning that this is my A, cool, and then this is kind of B right there, and I'll put another one down here, but you'll see this is horizontal. If it's the opposite here, then B is longer. Here's your A here, right? It's more of a vertical, maybe like a football standing up on its side. Okay, so the major axis is going to be your longer axis. The minor is going to be your shorter axis. Okay, the foci here, how do you find those points? Okay, so it's always going to be on the major axis, and it'll be a C distance away from the center. Okay, and it'll go both directions from the center. Okay, and so here's how you solve it. It's either going to be B squared is equal to A squared minus C squared, or it'll be C squared is equal to A squared minus B squared. So notice, depending on which one's the major axis, is where, how it's ordered here, right? So how it's ordered here. And so if you notice with this one, all we did is solve for C, and so brought C over here and then subtracted B to the other side. So C squared is equal to A squared minus B squared. And so the way I always like to think of it is it's on the major, so this is going to be the major axis minus the minor. I'll say minor, okay. And so the way I remember this is if you have an ellipse like this, your foci is always inside, right? So it's going to be, this is A, it's going to be less than A. So you know subtraction. We'll see in the next sections with the hyperbola. Our hyperbola looks like this, and the foci is further out. So this is, I like to do addition because it makes it go further. Okay, so that's one way that helps me know that the foci is a subtraction problem. Okay, so going through here, it's really nice. I don't have an HK, so my center is going to be at 0, 0. So our center is at 0, 0. Now, under here, this is the a value squared. So a squared is equal to n of 9. And so a is going to equal 3. Okay? And we know that it's going to go in the x direction because it's underneath the x value there. So 3 and 3. Cool. Now the b value is just going to be 4, or b squared, so b is equal to 2. So we go up and down 2 in the y direction. Okay, and so this is our ellipse there. And now in order to find the foci, okay, so the foci is just the difference between major and minor, right? So c squared is going to be a squared minus b squared, which in this case is going to be, we want the squared value now, so 9 minus 4. So c squared is equal to 5. So c is equal to the square root of 5. Okay, and so this is going in both directions. And so I'm going to, a lot of times they'll ask you for the coordinate of the foci. And so since this is in the x direction, we're going to have root 5 comma 0, because it's not going to move up vertically, and negative root 5 comma 0 right there. And so root 5 is what, just over 2. So if I was to graph it, it would be right in there. That could be f1. And then right in there, that could be f2. Cool. So again, our major axis here, we could say our major axis is 6 units. Our minor axis would be 4 units. And then our center is at 0, 0. Cool. So obviously we are in, if you've watched 9-0, there's a bunch of different forms that we can put our equation in, if it's hyperbola or a circle or anything like that. I mean, obviously we're in 9-1, so it's probably an ellipse, but one thing that gives it away is, number one, that it's a plus. So the plus gives us a good idea that it's either a circle or ellipse. And then the other one that gives it away that it's an ellipse is that these coefficients are different in front of the variables, okay? And so what we want to do for an ellipse is we want it to equal to 1. So we divide by 144. So when I simplify this, this becomes x over 9 plus y over 16, y squared over 16 is equal to 1. Okay? Notice kind of the pattern here that goes with that. Okay? So now we're going to go through the same exact process. So our center in this case is at 0, 0. Our a value here, a squared at least, is 9. Okay? And so our a value is equal to 3. Again, that goes, since it's underneath the x, that goes in the x direction. So it goes 3 left and right. And now our b squared value is going to be, what's that, 16? So b is equal to 4. So this one goes up and down. As you notice, the major axis has changed, right? Since it's vertical ellipse. Okay, then to find our foci here, we do the same idea, but we're going to do c squared is equal to we would want to do 9 minus 16, but that's going to give us a negative number, right? And so we definitely don't want an imaginary foci here. So this is kind of where I talked about at the beginning of classes. Even though I'd labeled these A and B, they're important, but as long as you understand the concept of with the foci, it's always going to be your major axis minus your minor. To me, that helps a lot more. It's always going to be your major minus your minor for ellipses, okay? And so this becomes 7, so square root of 7. Now, difference with this one, example number 2 versus number 1, is this is the major axis is in the y direction now, right? So my equation for the foci are going to be, I'm going to have 2 of them. I'll have 0, okay, because again, we're moving up and down in the y, and so this would be root 7 and negative root 7. Okay. I really like this method of doing major and minor, and then adding and subtracting from the center, okay, because I'll show you something else in a little bit. But if I was to graph this, again, root 7, we want to graph it as a little bit further, like between 2 and 3 here, so shabam. And shabam if you were to graph them. Okay, cool. All right, so this next one, we are going to try to put it in standard form. Okay, so they give us the information that we've been finding on the last 2 problems, but now they want you to set up an equation, right? So here, this gives us a good hint, right? So our foci, okay, gives us our C value. So in this case, C is equal to 2, because if you notice, it goes 2 in each direction, 2 to the left, 2 to the right. And it says vertice is equal to negative 3, 0. How do I know if this is going to be, quote unquote, my A or my B? Well, we know this guy is going to be our major axis. And the only reason we know that is because it's along the same line as our foci, right? So this is going to be A is equal to 3. Cool. And so as I set up my equation again, I want it to be something like this. Y squared over B squared is equal to 1. Cool. So now I can figure out my A squared value, right? So A squared would equal 9. And now, in order to get my B squared value, I do need C squared, which in this case is going to be 4. So I use the equation C squared is equal to A squared minus B squared, or as we talked about last problem, the major minus the minor, right? So C squared is 4, and so our major axis here is 9 minus B squared. So as I solve this out, so negative 5 is equal to negative B squared, and so 5 is equal to B squared. It's very tempting to take the square root there, but I don't actually really need the square root, right? Because I'm trying to set it up, and I'm looking for B squared. I want that as part of my equation, so I can stop right there and call this guy 5. So that would be the standard form of an ellipse with foci at negative 2 and 2, and vertices at negative 3, 0, and 3, 0. Cool. Okay, so number 4 here. So foci, same idea. We have a C value of 4. Now the vertice is something, right? It's 7. But is this going to be my major or minor axis? So if you notice, so here, because the y values are your foci are in the y values, that tells you it's going in the y direction. And these guys are also in the y direction. So this would be your major axis here. And so again, you can plug in whatever value, but the big important thing is the fact that that is your major axis. Okay? And so if I want, I can call this A. So I want C squared, which is 16, A squared, which is 49. Now, if I have something like this, x squared over something, y squared over something is equal to 1. Now, this time we know that our y is our major axis, so we know this guy's going to be 49. Okay. So when I set up my equation, I've got c squared, and this is the case a squared minus b squared. But now my a is under my y. But as long as you, again, keep in mind that major and minor idea. So I subtract it over, so I end up with what, negative 33 is equal to negative b squared, so b squared is equal to 33. Now I don't want the square root, I want the squared value, so I want to keep that 33. Okay. So that would be your idea for those. Okay. I apologize, I was getting too excited with solving these. It says, and sketch a graph. Okay, so we'll come back to sketch a graph real quick. So my 0 is here, or sorry, my center is at 0, 0. This one is, the major axis is in the x direction for number 3. So therefore, I'm going to go 3 in each direction. 1, 2, 3. Okay. And then here, if I am actually graphing it, I do actually want my b value, so that would be square root of 5, right? So square root of 5 is just over 2. So 2, I'm asking for a sketch, so it doesn't have to be ridiculously accurate, but pretty close. Okay. Same idea, but for number 4, right? Our foci, or sorry, our center is right here at 0, 0 still. My major axis is up and down 7. Okay, sorry about this. This goes off just a little bit off the graph, but that's okay. 1, 2, 3, 4, 5, 7. Right, and then in this case, my minor axis is going to be in the x direction, and this is what, square root of 33. We know what 36 is, right, which is 6, so just under 6. Just under 6. So this is a nice, beautiful vertical ellipse. Okay. All right, number 5. So this is where it gets a little bit trickier, right? So now we're talking about endpoints. We no longer have a 0 involved in the x or the y direction, right? So we need to put a little bit of thought in here, okay? So you'll notice with these guys, they always have something in common though. They'll always have like an x or a y in common because we're dealing with the major and minor axis are going to be horizontal and vertical lines. So either the x or the y is in common, right? So in this case, it says the major axis is right there. We've got 2, 2 to 8, 2. So if you look here, the y stays consistent. So that means that I'm in a horizontal direction, right? So the y stays consistent, so the x is my major axis. Cool. So if I do that, my a value in this case, it tells me the whole thing, okay? In previous problems, we told you where, kind of where they're at. So here the difference is 6, so the midpoint in the middle of it is going to be 3. So a squared is 9. Now the minor axis, right, the x stays the same. So b is equal to, in this case, we have a difference of, this case, it's going to be -2. So, but still, the idea is kind of 2. So b is going to be 1, half of that, square it, so that's going to be 1 again. Okay, so now as we solve this, if I do a quick graph, if you notice right here, I'm gonna, maybe don't draw this part, just listen for a second. So if I go 2, 2, and 8, 2, which is way over here, I'm gonna have something like that, okay? That is my major axis. My minor axis is gonna be at 5, 3, and 5, 1, right? So, and there is my minor axis. Okay, beautifully drawn there. So if you notice, right here would be my center, right? So my center is going to be at 5, 2. I like to draw it because I'm a visual person, but if you notice, it's always going to match these guys, right? So the ones that get repeated. So 5, and then over here, 2. Okay, so that's your center. So now we're going to have it look a little bit different. We know this is the setup. So since our center is not about the origin, we can do x minus 5 opposite h and opposite k. Now I just put the a squared and the b squared values, which I called a over here. I think I'm a little bit losing my mind today. So the a squared, again, is in that major axis, so that's going to be 9, is in the x direction, and your minor is going to be in the y direction, so that's going to be 1 right there. Okay. So unfortunately, this graph goes a little bit short, but here, if I did 8, let's call this, we'll call this 6, 7, 8. So 8, 2, and then my minor axis is going to be in between these 2 points. So that would be my ellipse. Super beautiful. All right, good. We're having a good time. Okay, so this is when it's not centered about the origin there. Okay, so good example there. So we've got a few more examples here. So number 6, we have it set up very similar to the ones we've done before, just the center is a little bit off. Okay, and so there's, if you look in a trig book or anything like that, they have equations for all of this stuff. But again, I'd like you guys to understand it and see where the stuff is coming from. So center opposite h, opposite k. So -1, 2 is going to be my center right there. Right, so in the x direction, my a squared value is 9, so a is equal to 3. So 1, 2, 3. We know that because it's under the x. Your b squared is going to be 4, so b is equal to 2. So up 2, down 2. That's our ellipse there. And then it says locate the foci. And so our foci, again, is c squared. I would do major minus minor. So c squared is equal to 5. So c is equal to √5. And so, again, on previous problems, we would just see which direction the major axis was and put that in that same x or y variable. Okay? But unfortunately, my center now is not at the origin. It's not at 0, 0. This is my major axis, right, following the x direction. So what I like to do for my foci is, since it's in the x direction, we know our y is not going to change, right? So our y is going to stay the same. Now, here, whenever the center is not at the origin, what you're going to do is you're going to do the center plus and minus the foci. Or sorry, foci, or we'll call it the c value. Okay, and so our center in the x is -1. So what we would do is we go -1 plus the c value plus √5, and then our center -1 minus √5. Okay. And even though that's not super pretty answer, it's totally fine. Okay, we don't want a decimal, we want an exact value. So that would be the equation for your foci. Okay, so that would be as far as we need to go. Okay. Number 7 here. Number 7, this one is completing the square again. So we want to get all the x's together, all the y's together, and then the numbers on the other side. So I'm going to put all the x's together. So 9x squared minus 36x plus 25y squared plus 50y is equal to positive 164. Now, since our coefficients in front of the squareds are not 1, we need to take out a GCF from here and from here. So we've got 9x squared minus 4x plus something plus 25y squared plus 2y plus something. And then here we've got 164 plus something plus something. Okay. It might help here, just so you don't forget, remember we do need to distribute in that GCF. Okay. So in order to get it, I like to set up my value. You keep the GCF on your standard form here for temporarily, right? And so again, I like to kind of set it up like that because it helps me take the b value divided by 2. That goes right there. If you're like, what? Where's he getting that at? You can check out my video on 9-0, and we talk about how this b divided by 2 is actually what you use for your trinomial there. Okay, and then you square it. So that's 4. That goes right there. And now what I really added, unfortunately I didn't just add the 4. I added 9 times 4, so I added 36. So if I added 36 on the left, I need to add 36 over here. Same process here, 2 divided by 2, so b divided by 2, which is 1. That's a positive 1. I square it. 1 right there. 1 times 25 is, I actually added 25, so I need to add 25 over here. So if I add those all together, I end up with 225. Cool. Now get it in standard form. Divide by 25, 225. And so I end up with, I might be running out of room, x minus 2 squared over 25 plus y plus 1 squared divided by 9 is equal to 1. Okay. So, sorry for all, I ran out of room here, but that's okay. Right, so our center is going to be at opposite h, opposite k, so 2, -1, 2, -1. Whoops. I said one thing, did the opposite. 2, -1. There you go. So in the x direction, my a value is squared, so that's 25. So a is equal to 5. So go 5 in each direction here. Wall-bam, wall-bam. Hopefully I counted that right. And then in the b, that is going to be 3 in each direction. So 1, 2, 3, 1, 2, 3. There is my beautiful ellipse. Okay. And now I need to figure out my c squared. C squared is the major minus the minor. So that's going to be what, like a 16. Okay. So if that's 16, then c is 4 away from the center in the x direction, because that's my major. Okay. So I'll write it here. My foci is going to be 4 away from the center. Okay, I'll put a little answer box here. So the y is going to stay the same at -1. Now my center is at 2 in the x direction, so I do 2 plus 4, so 6, and 2 minus 4, -2. So that would be my 2 locations for the foci. Okay. Okay. Number 8 here. Kind of 2 questions in one, but we got to set it up and then see if it fits through. Okay, so a semi-elliptical archway over a one-way road has a height of 10 feet. So always draw these, right? So semi-elliptical means half of the ellipse, and it says it's got a height of 10. Okay, 10 feet. And that will be always the max height, right? So not just any random height, but the maximum height there. And has a width of 40 feet. Your truck has a width of 12 feet and a height of 9. Will your truck clear the archway, right? And so if you're a good driver, you know your truck's going to be super tall. And so you're going to try to drive right in the center, right? Because that's the best chance you have of not hitting the bridge. Okay. So a lot of you guys, I love when we do this problem. You go, nope, your picture's not touching the top, so nope, it doesn't hit. It'll clear, right? Obviously that doesn't work. We've got to make sure that we set up the equation. So first, right, our biggest problem's right there or right there. So we want to figure out what is the height of the arch at those points. Okay. So first we need to set up an equation for these guys. So the big thing here is I already have the A or the B, whichever way you look at, of my minor, but be careful, this is the major. So that's going to be 20, right? So x squared over 20 squared, which is 400, plus y squared over 10 squared over, so 100 is equal to 1. It didn't tell us anything about like the origin and stuff like that, so we're going to make our life as easy as possible and we're going to call this the origin, okay, of the problem. So in order to solve this out, okay, so my next step, I have the equation here, but my next step here that I want to do is talk about the same idea. So here's our equation for the arch. Let me get a different color. So again, my question is right there, right? So it tells me that I have a 12-foot wide truck. So I know from here to here is going to be 6 feet, right? So that's 6 feet. And then from the top corner to the bottom, that is a 9-foot tall truck. Okay, so I'm hoping in the archway, 6 feet away from the center is going to be greater than 9 feet tall. Okay, and so as I solve through this, right, what I'm going to do is I'm going to multiply the entire thing by 400. Why do I do that? Well, I'm afraid of fractions. Okay, so if I do that, I get rid of the 400s cancel there, and then I multiply this one, I end up with 4y squared is equal to 400, right? So that makes it a little bit easier to swallow there. So now I know my x value that I'm trying to look for, so I'm going to plug it in. So 6 squared is equal to, plus 4y squared is equal to 400. So that's 36. If I subtract 36 over, that's going to give me 364. Now divide by 4. So y squared is equal, what's that, a 9 and a 1? Now I actually I don't want someone to tell me square root of 91. I want to know the actual height. So the actual height right there would be 9.539 feet. So all that's saying is I'll draw another nice little picture. Here's the center. 6 feet away from the center, the height right there is 9.53 feet. Okay. Well, our truck is 9 feet tall, right? So as long as you have an amazing driver that's not going to, snake back and forth or anything like that, or there's no bumps in the road because you only have half a foot there, so 6 inches, you are going to fit. So yes, whatever, will your truck clear? Yes, it will clear. Okay, that's on an H, sorry. That will clear there. So our truck would be super close, but it would barely clear. Okay, so my drawing was perfect. Awesome. I hope you guys enjoyed that. Here's a video if you want to check out a little exploration. But we'll come back next time with hyperbolas. Have a good night. Tell a friend.